Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic in sorting, that is a heap sort, guys. Okay, so before directly going into the algorithm, let us first learn how it is done exactly. Then we will be moving on to the algorithm, guys, because once you understand the logic, it is a piece of a cake for you guys. Got it? Yes. So that is the reason why first let us try to understand the logic. Okay, yes. So let me take a piece of paper. Okay, yes. So let us start. Okay, yes. So the input array which is given for us is 20, 30, 5, 10, 25, 40, 8. Okay, so this is the exact input array given to us. Okay, so the first step what we will do is for our understanding only. So basically inside your computer every data is written in terms of zeros and ones, and it is a consecutive data, guys. It is not represented in trees or graphs. So these kind of tree construction, graph construction, everything is done just for our understanding. Okay, yes. So just for our understanding, let us convert this into tree. Okay, so if you recall how a tree will look, guys. So with the two children, right? So 20, 30 left to right filling, and each layer should be filled completely. 5, 10, 25, 40 and 8. Okay, so if you are at nth layer, all the layers above you should be filled, and in your layer you should move from left to right, guys. So that is the logic. So if there are only 6 elements, or 1, 2, 3, 4, 5, only if there are 5 elements, means these 2 elements are not there. So at that time the tree will look in this way. Got it? Yes. Okay, so now let us continue. So once the first step is build a tree. Okay, so once a tree is building is done. Okay, so once a tree building is done, then you will check the condition, guys. So assume that you are trying to build max heap. Okay, so means what is the definition of max heap, guys? Every root or every parent should have the maximum value with respect to their children. That's the only logic here. Okay, yes. So I think everyone watched the data structures, right? So because that idea is really important. Okay, yes. So now what you will do is okay, so this concept of converting this tree into a max tree is nothing but heapify, guys. So in coding we use a function heapify to do this. Got it? Yes. So we'll be going through that logic also, so there is nothing to worry, guys. Okay, yes. So now your question will be, okay, from where should I start? So you will start at height by 2, guys, which is floor height by 2. So what is the length, guys? So what is the length? 1, 2, 3, 4, 5, 6, 7. So the height length is nothing but 7 by 2. What is the value? Lower bound 3.5. So which is nothing but a 3, right? Yes. Okay, so from third spot, so basically if you want me to write the spot numbers, so this is the first spot, second spot, third spot, fourth spot, fifth spot, sixth spot, seventh spot. So even let me write it here also. So 7. Okay, yes. So from a third spot you will start checking, guys, so whether it is a max heap or not. So is this point a max heap? So how you solve is, so let me write it in this way. So at the rate 3. Okay, so the first step which you will do is you will compare the left and right element. Is 40 greater than 5? Yes, means in a maximum you will store 40. Okay, so the next step is you will compare, is 40 greater than 8? Yes, means 40 is the final maximum value, right? Yes. So now what you will do is you will swap this 40 here and you will write down this 5 here. Got it? It's a quite simple swap, right? Yes. So the next step is at the rate 2. Okay, so what exactly you will do at 2 is, again you will do the same process. Is 10 greater than 30? No. Is okay, so is 10 greater than 30? So maximum is 30 only. Okay, so then you will compare, is 30 greater than 25? Yes, means 30 will be here. Got it? So there is no change there. Got it? Yes. So now again you will check it at the rate 20. Okay, sorry, at the rate 1, 20 minutes. Okay, yes, at the rate 1 you will check. So you will check whether, so just give me a second. Okay, so you will check whether 30 is greater than 20 which is true, means a 30 will come here in max. And you will also check, is a 30 greater than 40? This is a false, means in max you will get 40. Okay, yes. So now this 20 will go down and this 40 will come up. So at the end you will get a result in this way, guys. So 40, 30, 20, 10, 25, 5 and 8. So this concept of converting a normal tree into max heap is nothing but heapify process. Got it? Yes. Okay. So now once the tree is ready, max heap is ready, you will perform the the heap sort on this. So what exactly heap sort does is, the first step what it do is, it will swap the first element with the last element, guys. So means 8 will come up and 40 will go down. Okay, so once a 40 has reached down, it will reduce its height, the length of the tree by 1. So basically 40 is fixed at this location. So now there is no comparison with 40. So that's an ideal element, you can say. Okay, yes. So now on this tree, means now the tree is only this part. So on this tree again you will do heapify. Okay, and in this way you will continuously delete the nodes, guys. I think if I continuously explain this in this way, it will take really long time. So that is the reason why I'll be directly showing you in the book, guys. Okay, yes. So at the rate 7, you are swapping the first element with the last element. Okay, yes, you swapped them and now you will assume that the length is a 6 only. Got it? Yes. So again you will restore the heap property, means you will apply heapify on this. So means where you will check, we will check here, no change, here no change, here you will get this 30 above, 8 will come here. Okay, again you will compare, again 25 will come here, right? Yes. So after this you will get this as your max heap now. Okay, yes. So again you will apply heap sort. So again you will delete this 30. So to delete that 30, you will again swap these two, you will delete that 30. So the main reason why we are deleting the root always is because we need the maximum value outside, right? So if you store all maximum values in this order, so 40, 30, 20, 10. So what is this? This is nothing but ascending order, right? Yes. So that's nothing but sorting, right? Yes. Got it? Yes. So that's the magic, guys. Okay. Yes. So let us continue. So you will be continuously doing this. So here we saw 30 will come down and 5 will go up, right? Yes. Okay. Again you will do heapify. You will get 25, 10, 5, 8, 20. Okay. So again you will swap this 25 with 8. So you will get like this. And again you will perform heapify. 20, 10, 8, 5. Okay. So again you will swap this 20 with 5. Okay, so 5 will come again up, again you will perform heapify. So in this way, layer by layer, element by element you will remove. At the end, you will end up with a sorted array 5, 8, 10, 20, 25, 30, 40. Now you got an idea, right? So how exactly heap sort is working? So the main important step is heapify, guys. The first step which you should understand is heapify, like how exactly the heap is created, and the next step is this deletion. Got it? Yes. So first let us go through the code now. So I think now it's perfect time to go through code. So what do you say, guys? Shall we directly go from basic to code? Yes. So let us go from the first line of the code, guys. Okay? Yes. So once you want to perform heap sort on an array. So this is our array A. So you will be passing that array into our code. Okay. So the first step what you do is you will be building the max heap, guys. Okay. So building a max heap is nothing but that is a particular function, you can say. So that function is nothing but build underscore max underscore heap. Got it? Yes. So we passed the array, okay, and heap underscore size of array equal to length. So inside this heap size variable, I am storing the length of a. So what is the length of a, guys? It is nothing but 7. Okay. So then I am running a for loop I length a by 2. So basically I am checking length a by 2, which is lower bound again, which is nothing but floor value. So if remember, for any floor value like 3.9, if I am doing floor value, floor means the minimum, right? So what is the minimum value here? 3. So in that way, what is the ceil value of 3.9? It will be 4. So in that way, ceil means maximum, floor means minimum. Okay. Yes. So you apply that and you will move to 1. So basically here we got 3. So we did for 3 to 1. So if we got here 10, you will do for 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That many times you will compare. Got it? Yes. So what you are doing internally is you are doing max heapify, guys. So what is max heapify? So that is one more function. Okay, guys, here the more concentration is needed, guys. Okay, yes. So please concentrate. Max heapify of a comma I. So I is the index at which you are doing. So assume that we are doing at 3. So let me draw down that tree. Okay, 30, 5, 40, 8, 10, 25. Okay, yes. So assume that I am doing max heapify here. Okay, so first thing what I will do is I will check whether L is equals to left of I. So indirectly left of I is nothing but 2i guys, the formula. Okay, so 2 into I. So what is the value here? 3, 2, 1, 4. I think it's not visible, right? 4, 5, 6, 7, right? Yes. Okay, so what is the left child value is nothing but 2 into I. So 3 into 2, what is the value? 6. So 6 is our left child. Similarly 2i plus 1 is nothing but our right child. So this is our right child. So I am pointing two values to those addresses. Okay, if L is less than heap size. Okay, so if our left value is less than our heap size, so what does it mean guys? It means we are not having any left child, right? Yes. Okay, sorry for that guys. So if it is less, so assume that here we got, here these two elements are not there guys, just assume in that way. Okay, and now we try to calculate the left child of this third element. So what will there's a left side will be 6 and right side will be 7, but our length, that is nothing but heap size, is 5 only, right? So because we are having only 5 elements, so at this moment this condition will go false, right? Hence this loop will be shifted and you will be getting the largest value as I. So in that way it will work. Okay, yes. So here we are having the value. So what we are doing is it is having a value. So you are comparing A of L is greater than A of I. So you are comparing this value with this value. So which is maximum? So that location you are storing here guys. So if this is maximum, you are storing the L address here. If it is not, you are storing the I address here. Got it? It's a quite simple logic guys. Okay, yes. So once this part is done, again you are comparing with the right part. So basically this comparison is done. We got one maximum value. So what you should do, you should compare again this max with this, and then only you can swap it, right? Yes. So again I am checking here the second condition with the right child. Okay, I have checked it. Okay, so now I think I got some change. So here what it will happen guys, here you will get getting 40 and here you will get 5, right? Yes. So that kind of a changes are done. Okay, so once that change is done, again you will do max heapify, because if there is a change at some point, so if you observe even here, so just give me a second, yeah, here, so here I applied heap sort, sorry, just give me a second, where exactly it is there, so just give me a second guys, yeah, here this is the result, right? So if I apply heap for this, so here is there any change guys? No, because both of them are minimum, right? So this is not there internally, so this is minimum, so again here this is minimum, no change. Here if I do, I will get this 30 here, right? Yes, but again again here also there is an issue, right? So basically here 30, 25 and 10, right? Okay, so here we swapped these two elements, and once that swap is done, 38, 10, 25, 5, 40. So again you should start checking from here guys. So again you should check here, again you should check here, because here the condition has been failed after shifting them. So that is the reason why you will again do max heapify if your largest has been changed guys. Got it? You got the logic, right? So if the largest has been changed, you will recheck it. Okay. Okay, so this is the concept of max heap. So you identified left child as L, right child as R. You are checking which is max. So once you identified max, if there is no change, there will be no change. If there is any change of largest, you will exchange them and you will again apply max heapify. Got it? It's a quite a complex logic, but it's easy guys, if you understand. Okay, yes. Okay, so whatever is updated, so only at that point. So basically if you swapped, so here what we swapped, so here we swapped 1 with 2, right? So once this swap is done, you will apply max heapify at this point only. At 2 only you will apply. There is no need of checking at 20 again. Got it? Yes, it's a quite complex logic, but it's easy. Okay? Yes. So in that way you will continue until there is no change in your tree. Okay? Yes. So once this max heapify concept is done, your building is done. Okay? Yes. So now we are done with a single line of code guys, to be clear. Okay? Yes. So once this building of a heap is done, max heap is done. So what we can do? We can start deleting the first element, right? Yes. So for of I, length A down to 2. So basically if your length is 7 elements, so you will continue from 7 until you reach 2 guys. Okay. So what is the first step? You will exchange the first element with the last element. If you recall, that's the exact step which we did guys. So we always swapped the 7th element with the first element. So because we are having 7 elements here. Got it? Yes. And the next step what we are doing is heap size equal to heap size minus 1. Okay, then you are performing max heapify at 1. So this process is repeated continuously. So that is nothing but these steps guys, I told you, right? Yes. So I hope everyone got a clear idea, right? So now heap sort. So the code might be a bit confusing in the first stage, but please revise the code, guys. Just to go through the code carefully, like concentrate for some time. I have written the hints also. So these two lines are checking the indexes of right and left. So this is checking whether left is max or the center root is max. So this code is checking whether right is max or the max value is max. Here, if there is any swap needed, we are swapping it. Okay. Similarly, here we are building the max heap. We are deleting the elements and we are storing it in the same array, and we are decreasing the size by 1 and we are storing in ascending order, like minimum to maximum. Got it? Yes. So now you got an idea, right? Yes, how exactly heap sort is working. Okay. So now let us go through some of our basic questions which we are answering from our first lecture of this sorting. So the first question is whether it is based on structure or content, guys. So even if you give a heap which is already sorted, it will again construct the heap. It will delete element by element, guys. I don't know, it is a funny or something, but it will just blindly do the process, guys. That's the reason why it also belongs to structure, based on structure. Similarly, internal or external. So it is an internal algorithm because did we use any extra space, guys? No, we are just storing in that tree only. Remember one more thing, this tree is just a representation for our understanding, guys. So the whole game will be done in this array only. Got it? Yes. So is it a stable or unstable algorithm? It is an absolutely an unstable algorithm. If you want, you can take some cases where two values are same. So as it is doing heapify, it can anytime it can switch those values, guys. So that is the reason why it is unstable. Okay. And the best, worst and average cases will be n log n. So the basic reason again here also is we are again doing here. So if you observe length a by 2, this a by 2, how many times this loop will run, guys? So it will run only for log n times, right? If you observe carefully, yes. So that is the reason why this is nothing but a log n. Got it? Yes. So if this complexity is a log n and if this complexity is n, so length of a down to b, right? Yes. So means it is obviously doing from length to 2, which is nothing but if you are having length n, you are doing for n minus 1 times, right? Means it is nothing but n times approximately. So n into log n. So it is in total n log n. Got it? Yes. So even in the worst case also it is doing the same process, right? Hence the complexity of it will be big O of n log n. Got it? Yes. So now I hope everyone got a clear idea with respect to this heap sort, right? Yes. So I know that the algorithm discussion might not be that much easy for me also to explain, but I think you are getting at least some basic idea, right? So you can just observe the code carefully, like spend 30 to 40 minutes with the code, guys. If you are having more time, you can just try the code also. You can just go to Google, you can check the code and you can try practicing it. So even that will increase your clarity on the code. Okay. Yes. So I hope everyone got a clear idea on this heap sort. So in the next lecture, let us go through the concept of quick sort, guys. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.